Okay, so what we're going to do today is we're going to go ahead and we're going to start with reviewing what we talked about on Friday with 12.3, and that is finding the slope of the graph. And so we can write an equation to find the slope of the graph, and then we can actually find the slope at a specific point. So the first step is finding the equation for the slope of a graph. So we use the formula, f at x plus h minus f at x all over h. And really we use f for the function, and our function today is going to be g, so we're going to use g of x. So the first thing we do is we plug into the x spot x plus h. So this will be 1 over x plus h plus 1 minus the original function 1 over x plus 1. And then the whole thing is going to be over h. And this is what we're going to use to actually find the equation of the slope. And we've been doing this for several days now, but it's always good to re-see that and work through that. Now, because our values are both fractions, we're going to go ahead and we're going to combine them into one fraction. And so that means I'm going to have to multiply this by x plus h plus 1 on top and bottom. And I'm going to have to multiply this by x plus 1 on top and bottom. And so that allows me to have a common denominator on the bottom, which will be x plus 1, x plus h plus 1. And then we can go ahead and combine everything on top. So I'm going to have an x plus 1 from over here, and then I'm going to minus the whole thing here. So that really means I'm going to subtract everything that's in that parentheses. And that would be a minus x, a minus h, and a minus 1. So really just kind of taking this negative 1 here and distributing it to everything there. And so now we get this lovely thing, and I'm really truly being sarcastic with the lovely, but as we've seen before, the whole purpose of this process is that things are going to go ahead and cancel out. So what's going to cancel? Well, these x's are going to cancel, these 1's are going to cancel, and we're left with that negative h over x plus 1, x plus h plus 1. And what I had forgotten to work with was this lovely h on the bottom. So there's really a whole nother h below that. And so we've talked about this before, where instead of dividing by what we could turn this into as a fraction, we can multiply by the reciprocal of that. That doesn't look very nice, so let's fix that. And now we get more canceling happening. And so now we're going to end up canceling out this and this. So now we have a negative 1 over x plus 1, x plus h plus 1. And now we can apply the idea of the limit. So this whole idea was really the limit as h approaches 0. And we couldn't do that because as long as we had this h on the bottom the whole time, we were dividing by 0, which is undefined. So we're always working to simplify that, so now we don't have just an h on the bottom. So now we're going to apply that limit as h approaches 0, which means now we can do that direct substitution where now this h becomes 0 or goes away. So now our formula for the slope is negative 1 over x plus 1, and then this turns into an x plus 1 also. So an x plus 1 times an x plus 1 is x plus 1 squared. And that's the formula for our slope. Now we can go ahead and calculate the slope of that tangent line at this point, which really means because my formula only has an x, I'm plugging in this value 3 into that slope equation. So now it'll be negative 1 and 3 plus 1 squared. So negative 1 over 4 squared, which is negative 1/16. And so that would be the slope of our tangent line. And so now that we've kind of talked about plugging things into here, then on Friday we moved to the limit as h approaches 0. So now we're taking that one step further and we're defining what this process is called and relating it to our calculus. So the calculus was studying rates of change. Rates of change are related to slope, which is really the tangent, because we always talked about how tangent and slope were the same. So that's all related. And now we have a technical term for that, the derivative. And I know I've been saying this, that it's the derivative for a while, but now we're getting that definition. The derived function is called the derivative of f at x and is denoted by f, that's our little prime, f prime of x. So really, when there's one little prime there, it's the first derivative. If there's two, then there's a second derivative. So you can keep finding derivatives of functions. And each of them denotes something else. So the first derivative is usually speed. The second derivative is usually acceleration. And then the third derivative, I believe they call a jolt. And so it's all related to what's happening in the real world. So now we just have a technical term for what we've been doing so far. So nothing is really changing. We're doing the same thing, just now have a definition for it or a term, vocabulary word if you want. So now we can say find the derivative of f of x if f of x is 3x squared minus 2x. So still doing the same process, the limit as h approaches 0 of f at x plus h minus f at x all over h. And so we go ahead and plug in our information. So I'm going to go ahead and apply the limit until, I'm going to wait to apply the limit till later, till I've simplified. So I'm going to go ahead and plug in 3 times x plus h squared minus 2 times x plus h. I'm going to go ahead and work on my color coding skills again. So that was the first part. Now I'm going to do the minus the f of x. So I'm going to subtract this whole thing, which meaning I'm really going to distribute a negative to those. And then the whole thing's going to be over that h. So we're going to work on simplifying this, and that'll allow us to find that derivative. So now this will be 3 times x squared plus 2xh plus h squared minus 2x minus 2h minus 3x squared plus 2x. And so I'm going to go ahead and rewrite this really quick. This is really going to be a 3x squared, really because I'm too lazy to rewrite the whole thing again. And the 3 times 2 gives me 6xh, and then 3 times that is 3h squared. And the whole thing's over h. And again, our whole purpose here is we want things to cancel out. So this 3x squared will cancel out with the negative 3x squared. The negative 2x will cancel out with the positive 2x. And so now we're left with the lovely equation of 6xh plus 3h squared minus 2h. And it's all over h. So we're going to go ahead and start canceling out h's. So this is really like 6xh over h plus 3h squared over h minus 2h over h. So we can separate that out because there is just one thing there, and then we can cancel out some h's. Which now leaves us with the ability to apply the limit as h approaches 0. So as h approaches 0 of 6x plus 3h minus 2, and now we apply h approaches 0, so this really turns into 0, gives us a value of 6x minus 2. So our derivative is really 6x minus 2, and our derivative is really the slope of the tangent line, which represents speed. So now we're going to do the same thing. We're going to go ahead and find the derivative for the function square root of x, and then we're going to use that to calculate slope. So let's go ahead, square root x plus h minus the square root of x all over h. So on this one, because we have those square roots, we're going to have to go ahead and rationalize that numerator. And to rationalize the numerator, we multiply by that conjugate. So the square root of x plus h plus the square root of x, and then we multiply by that on the bottom also, because we can't really change the expression, we can just change how the expression looks. So this is really multiplying by 1. Now, by doing that, we're going to get that magical multiplication that happens on top, and when I have this times this, it's really, since they're the same, it's a square root of x plus h squared, and the square root cancels out, leaving us with just the insides. And then our middle terms will cancel. That's why we have the conjugates here. And then we get minus x. And so that's all over h, square root x plus h, plus square root of x. X's will cancel out. H's will cancel, leaving us just with a 1, because anything divided by itself is 1, except for 0. So now we can actually apply that limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. So since h is approaching 0, this becomes 0. And now I have the square root of x plus the square root of x. So this turns into the derivative of x, the derivative of the function at x, is really equal to 1 over 2 square roots of x. Because when I add these two together, that means I have 2 of them. So it's 2 square roots of x. Now that I have the derivative, I can now actually figure out the value at each point. So I'm just going to plug in 1 for the first one. So at 1, 1, the derivative at 1 is 1 over 2 square roots of 1, which is just 1/2. So that's the slope of our tangent line. And then at 4, 2, the derivative at 4 is equal to 1 over 2 square roots of 4, which is 1 over 2 times 2, which is 1/4. So again, the slope of our tangent line at those points. So again, this is really reviewing what we've talked about and reminding you of all these different techniques we've already talked about. So kind of pulling all this stuff together using just really different notation on the question. Find the derivative of f at t if f of t is the square root of t plus 5. So again, plug in x plus h plus 5. And technically, I think we should do t plus h because our value is t and not x. But I have a hard time with my t's looking like pluses, so I'm going to go ahead and use the x for right now. Minus f at x, which would just be x plus 5 all over h. So again, we're set up to do the same sort of thing before. We have to get rid of those square roots on the top. So we multiply by that conjugate, x plus h plus 5 plus square root of x plus 5. So we do that on top and bottom. And I have no doubt in my mind that you guys are really smart. But the idea is that if you don't sit there and work through all of this process, you're not taking the time to put all of this into your short-term memory and processing over and over and over. The more practice you have with writing, the more that information moves into your long-term memory. So showing your work is not only for my benefit to evaluate, do you really understand the steps to get there, but it's for your benefit to move the information to your long-term memory. So that way, if you go to calculus next year, you have all that information stored there, and it takes less relearning or reviewing to get to where you need to be. So on the top here, x plus h plus 5 minus x minus 5 all over h times the square root x plus 5 plus x plus h plus 5 plus the square root of x plus 5. So again, looking for canceling, boom, 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 and then we get canceling here. So now I'm just left with a 1 on top. And so now we apply that limit as h approaches 0 of 1 over the square root of x plus h plus 5 plus the square root of x plus 5. Again, since h approaches 0, this goes away, and we get 2 of the same on the bottom. So that means that my derivative f at t is technically 1 over the square root t plus 5, and there were 2 of those square roots, so there's a little 2 in front. And that is our derivative. So now we have another problem, again with the fractions. So again, reviewing how to find those derivatives. So h at t is really the limit as h approaches 0. And then we're going to go ahead and plug in 6 over 5 minus t plus h. I'm going to go ahead and try this. Maybe a t like that. There we go. Minus 6 over 5 minus t. And the whole thing over h. So again, h is on the bottom, can't apply the limit yet. So because these are fractions, we're going to try and turn them into one fraction. So combine them, need a common denominator. So this will really be multiplying by 5 minus t minus h. I distributed the negative here on top and bottom. And then over here, I'm going to have to multiply by 5 minus t. And so now this will go ahead and combine. So I'm going to have 6 times 5 minus t minus 6 times 5 minus t minus h. Whole thing over 5 minus t and 5 minus t minus h. And the whole thing over this h, I'm going to go ahead and multiply by the reciprocal, so multiply by 1 over h. So that way we can just put that into one big fraction. So this is now going to become 30 minus 6t minus 30 plus 6t plus 6h. And the whole thing over h times 5 minus t times 5 minus t minus h. So let's see, our 30s are going to cancel, our t's are going to cancel, and we're left with 6h, and those h's will cancel. So this is now going to become the limit as h approaches 0 of 6 over 5 minus t and 5 minus t minus h. And since this approaches 0, we're going to place h as 0, so that just goes away, which means I really have 6 over 2 5 minus t's. Not 2. Whoa, they're multiplied, so it's squared. Let's just fix that. 5 minus t squared. And that's our value for the derivative. So let's write that out in technical form. Oops. It's h, so the derivative of h of t is equal to 6 over 5 minus t squared. Okay, your assignment for tonight, 12.3b, page 833, numbers 9 through 17, only the odds, and then 21 through 26, and this is all. You're going to do all of those.